policy in terms of energy pricing, the importance of non-agricultural employment to cope for farmers to cope with water scarcity, and also the role of technologies. And talking of technology, at Insan Laboratory, where he is the director, he is spearheading a huge effort to bring Israeli technologies to address water scarcity issues and global energy and development challenges relating to agriculture and sustainable agriculture. So it is a remarkable research effort that he has put in already, and I look forward to his talk today. Welcome again, once again.
Thank you. So, good morning, everyone. I'm very honored. Thank you very much for the invitation. Disha, I wish you hadn't mentioned the previous speakers in the series because now I'm feeling a little bit intimidated. Um, but I am truly honored to be here, and I'm honored to be a guest at this institution. Such a prestigious institution, such a prestigious opportunity to discuss this issue with. And I'm also honored that I had the opportunity to be a guest not only in this institution, but in your country over the last 15, 16 years, trying to understand these issues. Both of our countries, I'm from Israel, are struggling with and have been struggling with water issues for a while, and will probably continue to struggle with them in the future. And part of the inspiration for me and my colleagues and my students to be able to work here is to encourage a collaboration and a collaborative effort to learn and understand these issues so we can tackle them together. If we succeed in doing that, then the insights that we will obtain from this learning will be relevant far beyond our own two countries. This is becoming a global issue. So let's keep that in mind as we discuss this. And I'm feeling very fortunate to be here because I hope to be able to learn and to discuss these ideas with you. So please feel very free during the talk to anytime you want. You know, Israelis, we don't have any manners really. One thing we lack is manners. So I'm used whenever I give a talk that people don't even raise their hand, they just jump in. And so please feel free to do the same. It will not be considered rude in any way. In fact, I would prefer that we have an interactive discussion. So please don't hesitate, okay? And even if it's something clarification or anything that is not clear, please feel very, very comfortable to jump in. So the question that I chose for the title of the talk is a question about whether irrigation in India can be sustainable. And there are two senses in which I want to raise this question. First, there is the widely perceived notion that it is not sustainable at the moment. And from that perspective, we can ask whether it can be made to become sustainable. And the second thing, which I'll only touch upon a little briefly at the end, is whether in fact we know it is not sustainable. And I'll explain what I mean by that later. The hint is that, of course, hydrologically, it's not sustainable because physically water reservoirs are being depleted. But as economists, maybe we can consider that, maybe we should consider it from a slightly broader perspective, and I'll come back to that at the end. This is an overview talk. I'm not going to go, we'll cover a bunch of different studies, some of which I'm involved in, some of which other researchers are. I won't go into the technical details of many of these studies, but please, if you're interested, I would love to answer any question. I know you all extremely well trained in the disciplines, in the research methods that have been used here. So I'd love to also get into more technical discussions. Please feel very free to ask. Okay, so basically what's the issue we're talking about? We're talking a pervasive global issue that basically is about the fact that in many parts of the world we have a depletion or a decline in the availability of fresh water in storage, in natural storage, whether it's in surface water bodies, to a large extent in groundwater aquifers, which store enormous amounts of fresh water in many parts of the world, but they are running out. And one of the most amazing ways that we can see that now at the global perspective is through remote sensing. So amazingly, NASA has a special satellite mission, which has been working for more than 2 decades now, and is able to basically, it's a pair of satellites that revolve around the planet and can measure small changes in the gravitational field of the Earth, the local gravitational field of the Earth. And they've been picking up signals in specific parts of the world that indicate a gain in mass or a decline in mass. And some of the scientists working on this mission have been able to use some modeling to remove certain confounders from this data and identify the rest of it as signals that are coming from an accumulation or a depletion of water which is stored in these locations. So that's incredible because without that, all of our data would be based on ground measurements in aquifers, which are limited. We have a lot of data from that also, but it's problematic, it's sporadic, it doesn't cover. Now we have a really global picture of what's happening to water, freshwater storage. And basically what we see is that the picture is mixed. Wherever you see a blue area here, it means actually there's a gain in water mass. Where you see red, there is a decline in water mass. And we see that if you look at the global average, there's kind of, about equal amounts of areas which are blue and red. So, overall fresh water is not, as a global amount, not necessarily showing a dramatic decline. But water, unlike carbon, is a local issue. The problem has global extent, but the local manifestation is very important because water is not so easy to transport. If it was, we could just move water from the blue areas to the red areas and we would be fine, but we can't transport water so easily. And so everywhere where there is an imbalance, a strong trend, it's a reason for concern. We will focus on the red areas today because that's where water scarcity. It doesn't mean that blue areas are doing fine. Too much water can also be a problem. But red areas are areas where there is a growing sense of scarcity of water. Here is India. We know that one of the major hotspots of depletion is actually in northwest India, in Punjab, Haryana, those areas. There's actually better maps, a little more updated, that actually show that the declines are actually more pervasive in India, especially if you look at also data. One of the problems with this data, it's kind of, the resolution of that is kind of coarse. It's around 100 kilometers by 100 kilometers. It doesn't have finer resolution. But when you complement that, and this is a recent paper in Science that really collated actual groundwater observation from wells from all over the world, massive data collection effort. And the summary of that, and when they looked at the trends, different parts of the world, we see these are the major areas in the red where you see the major hotspot of groundwater depletion. We have parts of the US, of Mexico, that are famously dependent on groundwater in the central high plains, California, some parts of Mexico. We have some parts of Europe, especially around Spain. We have North China, which is also a big groundwater economy. Some parts of Central Asia. Iran is really a hotspot, but India is one of the most well-known examples of a place where groundwater is being running out. Especially important because India is the world's #1 consumer of groundwater. And so there is a lot of concern about what that means. And it's not just the Northwest. There are many parts of the country where you see these red trends, especially in the South, Northwest, West, Gujarat, Rajasthan, and those areas. Now, why should we care about this? We are, after all, economists, not hydrologists, but the concern is that as this fresh water becomes more scarce, more difficult to access, when the water tables fall, first of all, the resource becomes depleted, less available, it becomes more expensive to access it. So access is going to be gradually restricted. And fewer farmers, who are the main consumers, will be able to access it. So we are worried about what that could mean for income, what that could mean for the prospects of rural development, which is going on quickly. But as many scholars feel that irrigation was a big part of what spurred the agriculture and rural development. If access to fresh water will decline, there is a concern that it will make it harder to expand the development strategy to other parts of the world that have not yet developed their irrigation, and also constrain the growth where it's already practiced. We are also worried beyond this from a development perspective, from the point of view of food production. The world is facing a complex food challenge. My colleague Dr. Alon Chepon will speak about that this afternoon. The world is facing a global food challenge. There's a need to increase food production while reducing its environmental impact. If we lose access to irrigation, which supplies a huge amount of food production, that could be problematic. That's a real threat to global food security. And finally, especially as we enter an era where climate change is going to be more and more manifest in terms of impacts, access to fresh water and irrigation is one of the main ways in which we expect populations to be able to adapt to climate change. Because whenever our disruptions in rainfall patterns, whenever temperatures rise and evapotranspiration increases, freshwater irrigation is one of the ways you deal with that. And if this resource becomes more scarce, then this adaptation strategy may be jeopardized. So for all of these reasons, people are really concerned about these water issues. In a recent effort, I've been there from the Global Commission on Economics of Water that was convened last year. We tried to quantify the extent of these issues, and there are huge, very large fraction of both population. These bars represent percentages in the red of global population, of low development population with low human development index, of crop food production, and especially of irrigated crop food production that are situated in those locations in the orange area where this trend is negative, meaning where depletion takes place. So when you quantify what extent of our population, of economic systems are exposed to this, it's very substantial. So this is a big problem. Now, what's the cause of the problem? The cause of the problem is that we are taking more water out than goes into these storage. It's basically like a bank account. It's been building up over variable amounts of time, in some places centuries, some places thousands of years, some places decades, depends on the geology and the climate locally. But in all of these places where you saw the red areas are places where we're taking out more water than is coming in through natural processes, and then that water ends up evaporating or running into the ocean. It's actually contributing to sea level rise globally. So we're moving water from these reservoirs to the atmosphere or to the oceans where we can't utilize it anymore. And because the main source of these withdrawals is agriculture, estimates are globally around 80% of all the water we extract is by agriculture for irrigation. We need to figure out how to reduce these withdrawals by agriculture. That's the challenge. Now, the good news is that agronomists, by and large, feel there is tremendous technical potential to reduce the amount of water we use in cultivation without even harming food production. So we can really be more efficient, technically, in the technical sense, in how we use water for irrigation to affect these crops. It is technically, according to most agronomists, very much feasible using existing technologies. So those are good news. And that has become a consensus of sorts around scholarship on making food systems sustainable, that this is the key. If we can improve the efficiency of irrigation, the efficiency with which water is used, in the sense of using less of it to cultivate the same amount, this is the way that this problem can be solved. That can help us slow down depletion where it's ongoing already, and also it can help adapt. So in places where the water is already has been depleted and people are losing access to that water, we can use that remaining water more efficiently to maintain the agricultural production, even though less water is also available. So it's a strategy also to slow down the depletion and also to adapt to that depletion. Now, there are two important caveats. So this is kind of a consensus in the sustainability discussion. This is a way to solve the water crisis. But there are two important caveats to this that one of which I won't go into and the other will come in the end. One caveat is a physical hydrological issue which has to do with return flows. So the idea is if I take less water from the ground and then irrigate, use it less for irrigation, I can save water. But some people claim that if you take too much water from the ground, when you irrigate too much, whatever water is not used by the plants actually percolates back into the groundwater. So actually you're not using it, you're not losing it. And if that's true, then just improving the efficiency may not stop the decline of the water. And that's actually a big debate that hydrologists and agronomists have. Unfortunately, still not resolved, and it's very important for this discussion. So, but we leave that aside because to some extent, some of that water does evaporate. So it's not clear how much of it does that, but let's just assume for our discussion that there is still that this logic of improving water use efficiency is not completely flawed. It might be lower than what people think, but it's still something that needs to be worked out, and it's still the consensus. The other caveat is the thing I mentioned before. I'll come to that at the very end. For now, let's assume that we embrace this idea that the agenda to solve, the main agenda that we need to pursue to solve this crisis is to improve water use efficiency. Okay, so how do we do that? There are a bunch of different types of technologies. There are technologies that help to maintain more moisture in the soil, improve soil. When soils are healthier, they can store more water, so you need to irrigate less. There are a bunch of different technologies and practices that just tell farmers when and how much they need to irrigate. Some of which are very suitable for even like, low-income farmers, and there are simple heuristics. One of the most famous one is called AWD, alternative wetting and drying in rice cultivation, which is one of the crops that takes up the most amount of water. So this is just a system that tells the farmers, like once the water recedes, when you need to basically flood again and to what level. You use a measuring stick. It's been developed by IRI, the International Rice Research Institute. And it's a very simple heuristic. There are other technologies of this kind. It's one of the most famous. Basically just improving the scheduling of the irrigation to be more efficient. Recently, there's also direct seeding of rice, which says don't use nurseries in the beginning. We don't have to go into technicalities. These are things that are not one there? Yeah, great. So maybe you can, if I'm saying anything wrong, let me know. I'm always counting on the fact that there won't be any farmers, agronomists, hydrologists, so I can just like, with economists, it's worked really well, by the way. A tip for your job market talks, if you start talking about scientific stuff, all the economists kind of shut down. They won't dare to challenge you. They'll believe whatever you say. I've exploited that a lot. So just a tip between us. But there's always a risk that there'll be a rice farmer in the audience, so be careful. So, and recently, ICT, information communication technology, has also become a popular, promising way to do this. You know, with satellites and sensors and mobile phones, there's a lot of buzz around that, how to also use that to improve water use efficiency. Another category of practices is about getting the water just right to the crop rather than flooding a whole field. The simplest way is furrows, but also a very famous other technology is micro-irrigation, which are drip irrigation or sprinklers, which bring the water more efficiently to the crops. These are things that were developed in Israel, so we're very familiar with them. There are also attempts to use new seed varieties that have lower water requirements. So a bunch of different things, and of course, a major one is not technical, but about shifting crops from crops that take up a lot of water to crops that produce the same nutritional value with much less water. So those can go with dietary shift, and again, we have Alon here is an expert on that. He'll speak about this afternoon. So we have all these technologies, but of course, as economists, we know that that's not the end of the story, because ultimately, the decisions about who will actually make use of this technology will depend on the decisions that are made by many millions of farmers around the world. This is an example of one gentleman in Gujarat who's in his wheat field, where I did a lot of work there in the past, and he's flooding his wheat field. The agronomists have a lot of solutions for this farmer, but we as economists understand that the decision to adapt a certain technology is complex, and even when you have great technologies that work very well on paper and have proven themselves fully in controlled agronomic trials. The road from there to actually large-scale adoption by farmers, and not just adoption, but correct use of the technology, is a very long road. The human factor, the behavioral factor, the economic factor is something that my engineering colleagues often fail to completely underappreciate, and then reality hits them in the face when farmers, for some reason, refuse to take up their wonderful inventions and save the world with them, which always perplexes them. And for example, in the case of India, for example, like statistics from, these are old statistics, but they have not changed a huge amount. Most farmers still flood their field, not just for paddy, but even for other crops. So when we think about, especially in a context where farming is dominated by many small-scale farmers who face many complex constraints, we know from a very deep and vast literature in development economics that there are many barriers that farmers face, that small-scale farmers face, that stands in their way into adoption of these technologies. There's a very vast literature that has been looking at it, still very active field of research, that any improved technology, that many improved technologies, even when they are proven again technically, there are issues that prevent farmers from taking them up. It could be related to informational barriers, knowledge, financial barriers, risk, all kinds of market failures in inputs and outputs, very developed literature. But in this case, all of these barriers are joined by another set of barriers. As if they are not difficult enough to deal with, there's another set of barriers that makes it even harder, and that is that we are talking here about technologies that are supposed to help farmers reduce their use of a resource which is often a common property resource, which is often not regulated, which is often not priced. So not only are we expecting farmers to take up technologies which, like all other technologies that improve their income, all these barriers are still there. On top of that, the incentives to take up these technologies are also often missing. And this makes it doubly difficult, twice as hard perhaps, or much harder than just the normal income generating, productivity enhancing technologies. And it introduces another dimension into this entire field of research that needs to be thought about. By the way, not just water, similar challenges when we think about nitrogen fertilizer. Again, an input which is used very intensively and probably excessively, creates a lot of pollution, public health challenges. Similar kind of challenge also there. And for these kind of technologies, resource or efficiency enhancing technologies, this is a relatively young subfield of the field of technology adoption in general. Any questions, comments so far? Okay, so the big research question that we need to think about is what will actually drive farmers to shift their irrigation practices to these improved possibilities. And I want to propose a framework to thinking about that. And that framework consists of three broad categories of answers to this question. The first category of answers is that scarcity itself will drive efficiency. The idea here is that it's more about improving efficiency as an adaptation rather than as an avoidance of water depletion. In the sense that, in that point of view, is that some people believe that there's not much that we really need to do, because when scarcity, right now we are worried about falling water tables, and we see farmers are not really changing how they use water, but when they really feel the scarcity is the best driver of innovation and adjustment and adaptation. So once we see farmers will start to face a real scarcity of water, then we will see them, that will be the driver of their shifting of their way they do irrigation, and they will able to adapt their agriculture to this scarcity, and things will just work out by themselves. That's kind of a broad, simplified picture of the first category of answers. Scarcity will bring the problem will by itself solve itself through this coping.
That's too simple.
I agree, but for now I'm just very oversimplifying and just caricaturizing to some extent, just to kind of organize the discussion. But I totally agree that it's that's the case.
People simply leave on that.
Exactly, exactly. And in fact, that's what we see is actually happening more. So I just lost the teaser is given away. That's what we'll see. But let's get back to that in a few minutes. The other category of answers is that, and that's actually what most of us economists usually advocate, is that to solve this kind of problem, we need to internalize the cost of depleting the resource. We need to regulate it or price it in some way. You know, we prefer pricing, of course. That's how we were trained and taught. But any regulation would be better than nothing at all, right? And right now there's really very little in the way of regulation or pricing that's taking place in many countries, including in India. And the third is that is a more direct approach. A more direct approach, it is about not about creating the incentives, but about actually actively disseminating the technologies we want to see practiced through active public efforts and through subsidies, informational campaigns, extension to actually push these technologies in. So I want to organize this discussion into these three broad categories. Obviously, the question of which of these is the right amount is actually super relevant for policy. If this is true, then maybe policy doesn't need to do that much. If this is true, then we need to find ways to regulate and price and all that, which actually is a very difficult challenge. It's very easy to say that, and we keep hearing this discussion about how important it is to do that, but it's actually very hard to do. And the third one is actually, I think, perhaps the one most popular with politicians or bureaucrats, is to actually engage in active dissemination of technologies. And we'll see what we know about that. And I want to just go through with you with a bunch of empirical evidence that provides some hints to what the evidence is on how effective these different types of approaches are to this problem. Okay? There's not a whole lot of evidence. It's still something that we need a lot more of. It's a work in progress. So there aren't a whole bunch of studies. But let's see what kind of is coming out from what we already know. So all of these studies are in India. And there are 9 studies I want to go through all together. All I have, are experimental or quasi-experimental, so can give us some causally interpretable evidence, field evidence. And so we have 3 studies looking at the effect of scarcity, 3 studies looking at incentives, and 3 studies looking at the technology dissemination. And they're overlaid over a map of India which indicates, the degree of the groundwater stress. The colors indicate whether they find good news or bad news. So red indicates that we don't see evidence that this is working. And blue means we do find some evidence. Some of the studies here I was involved in, others are not. I don't know what I'm doing wrong, but the studies I'm involved in always end up being red, not finding any effect. And the blues one, I never get a chance to take part in those studies, so something needs to change. Okay, let's start with scarcity. So what's the theory behind scarcity? A simplistic theory, but a theory that says as water becomes more scarce, farmers, either out of anticipation of the resource running out, they see their water tables going down, they're very much aware of it, wherever you talk to farmers about it, they know exactly what's going on. Or after it's having already happened, adapting to it as a coping strategy, will find ways to manage with less water. And we know that technically there's a wide menu of technological options for them that can help them to find ways to do that. But do they actually do that? Do we see that that's actually happening? How do we answer this question? This is hard, right? Because we can't, if we want experimental or causally interpretable evidence about this, how do we do that? That's hard to do because we can't run an RCT with like depleting water in some villages or whatever. I don't think that would go well with any ethics committee. And so we have to look for natural experiments. And if you look, for example, in the climate change literature, there's been a lot of progress made to obtain causally interpretable evidence through exploitation of random variation in weather conditions, right, from year to year. But here we don't have that privilege. We can't implement that because here we want to understand how farmers respond to something that's gradual, a long time trend, not 1 year of falling water table, but like a decade of falling water tables. So that means because we want to look at variation in this kind of, slower, kind of slow onset process, we can't utilize temporal variation that much. So we have to find ways to basically exploit other types of variation, mostly geographical, in the trends. And how do we find the variation which is exogenous is the challenge. That's a great question. That's one of the things that can make this arrow not work, right? Very, very good point. I don't have a good answer to that. Please, please, please.
Major problem that I have seen entire and there are certain issues. What is technically known as evapotranspiration. How much you're taking out and how much is going back into the aquifers or the surface and what is lost. This minus that. And that is largely evapotranspiration. Not much technology has developed. Yes, Israel has done that, and many other things. And that is an externality problem. Conflict problem. And very difficult to handle that as a conflict problem. And that is where the second point, second set of.
I very much agree. I just want to say something about, before I answer your question seriously, which I actually totally agree with you. There's this conception here that in Israel, every single drop of water is used super efficiently. There's never any wastage. Now, it's not in my interest to break that bubble for you. But between you and me, and don't let this slip outside, okay? It's not that simple. I was recently shocked to find, I thought every farmer, I go around here telling everybody, oh, in my country, every farmer, like it's, actually, I thought every Israeli farmer has a sensor and it's automatically telling them, it's actually, I realized it's actually, most farmers have, there's also rule of thumbs of when they irrigate or when not. I would still think the efficiency is very high relatively, but it's not like it's like at the optimized to, at the 100% efficiency. Many problems also there, including some of the same behavioral things that we might encounter here. So just as a small caveat to that Israeli thing, even though I hear that all over, especially every farmer here, we were in Satara in the last few days south of Pune, there's this conception wherever you say you're from Israel, they're, oh wow, like, it's true, it's very, very efficient, productive in the sense, but we also have a long way to go. Now, I totally agree about your point that all of these things could make this not work. So I'm not laying this out as something that I necessarily believe in. I'm just laying it out as a potential theory of the process that could happen theoretically, and ultimately it's an empirical question to what extent it's actually happening, which is what we try to investigate. There are many things that could go wrong in this theory, of course, so it may not work. But still, it could work also, despite the common property resource issues. It could still be the case that the farmer has lower flow of water from their well, or they see the water table decline, and they make an adjustment on their own farm that enables them to manage with less water. That's kind of the possibility we raise here, and we want to know what's actually happening in the field. So empirically, it's very hard to do that because we have to find a source of variation between locations in the degree to which the resource is actually running out, and then exploit that to, and then use that to correlate the extent of that depletion to what farmers are doing. The problem is that if we just look at correlation between the rate at which water is depleted and what farmers are doing, that correlation could be interesting, but it may not be causal, right? Because, for example, maybe those locations in which farmers are richer to begin with or more technologically advanced to begin with, maybe they're already been pumping for a longer time or more intensively, and that's why the water table is falling there. And that's also because they're more savvy technologically, they're also using all these technologies. So that's just one example of a confounding factor in this kind of relationship. So the most studies in the space, what they utilize to identify natural experiments is geology. Geology has a lot of effect on what happens to water in ground, how fast it's being depleted, et cetera, and if you assume that either through that effect on water, geology itself, the structure of the rocks under the surface, under the, beneath your farm or beneath your village has no other effect on your farming practices, on your socio-economic circumstance, etc., then this could be a good source of exogenous variation. So there are three experiments here that I want to mention here. One is in Gujarat, in North Gujarat, where I actually worked in this during the end of my PhD. One in Karnataka, and one in Andhra Pradesh. And basically, all of these use some kind of geology as a source of variation in either how fast the water table is declining or at the likelihood of a well running dry. I'm not going to go into all the details because of time, but I'm happy to elaborate. And all of them use these kind of variation in geological circumstances to find, first of all, that what do we see as the causal impact of this faster depletion of water? Well, everywhere we see agriculture shrinking. So if we had the hope that, if farmers were able to actually adapt to the scarcity, we would see agriculture, the extent of cultivation remaining similar across these variation in degree of, in the rate of depletion. But what we see systematically is there is actually a shrinking of agriculture, either in the intensive or the extensive margin. So either they cultivate less water, less land, or they actually, in some cases, actually stop cultivating entire plots or altogether stop cultivating both. So it doesn't look like there is a very effective adaptation in either one of these cases. We also don't see that there is massive indications of large-scale adoptions of any water-saving technologies to the extent that we can see it in the data. The one thing we see happening again and again is exactly what you said, that instead, the main response in those places that are losing water fast, people are just shifting out of farming. Either they're migrating away in the case of Gujarat, or they're staying in the villages by finding other types of income-generating activities. So instead of a process where we see water running out, farmers adjust within agriculture and manage to sustain their productivity, the thing we see is more leaving agriculture altogether. Now that may not be from the point of view of the economic development of these households or communities, that may not be a bad thing, I don't know. It's hard to say, we have to monitor the incomes, what happens. But from the point of view of agriculture and food production, that's not a good sign, okay? These are some of the variation we use. So this is the study in Karnataka. Here we basically, the empirical strategy was there. That was covered about 100 villages all along the eastern side and the dry side of Karnataka. And in each village, we basically took a census of wells from the sample farmers, and we used what is plausibly random, the occurrence of the drying of their first well, to see how it affects their whole trajectory across farmers in the same village. That was the empirical strategy here. In Gujarat, we had a bunch of villages where we actually had geological data on the structure of the rock. We were able to find it, very fortunately, and we saw that leads to the correlation that I just described. Andhra Pradesh, similar. So roughly similar empirical approaches and pretty similar empirical results. So not great. If you're a scarcity leads to change advocate, sorry, it doesn't look really good for that theory. Let's move to the second broad category of answers, which is incentives. Please. Because the blue ones are not my studies, so I don't want to spend. No.
I know that. But I know red ones are disheartening, but
yes,
maybe blue ones perhaps have the right.
I agree. The blue ones are more, and we'll go to them now. In the case of the scarcity, there is no blue one that I'm aware of. So I didn't find any study that shows adaptation is effective.
Yeah, continental side. Let's be a continental side.
The blue ones actually, if you look at more closely, you want to really know what really makes them successful.
I fully agree with you. And one of the things I want to say is, look how few good studies we have. This is for all of you. Like, you need to make, we need more studies of this. Why do we have just a scattering of these studies? We need more of the blues to understand how the blues work, but we have so few good studies. So this is, if you're looking for a topic for your PhD, please consider working on this issue. We need to have these kind of approaches piloted and you know, on a large scale. This is so important for policy, and we have so little evidence. It's something I want to lament together with you. So I'll get,
Just one more.
yes, please.
One possibility is that simultaneously what's happening is some of these red one could be those places where the incentive to migrate or where rural urban migration forces are much more powerful, where they are closer to industrialization. But
Fantastic.
let's say in West Bengal, kind of thing where there are incentive to migrate or where the localization is not really happening.
That's a great, yeah, great comment. I just want to highlight, when it comes to exploiting variation and scarcity, we only have these three studies. The blue ones are studies of incentives and technology, which I'm getting to in a minute. In the case of this hypothesis, these are all the studies we have. Unfortunately, they're all red. But you're very right. In the Karnataka study, we had many villages, so we could look at what the impacts were in villages that were near to other types of like industrial employment opportunities and villages that were away. And we found that the difference was in those villages that all of them had the same effect on agriculture. None were able to adapt. So in both places, the effect on agriculture was negative. But in the places that had these other kind of industrial manufacturing jobs available nearby, the households managed to maintain their income levels. Their agricultural income went down when they lost access to water, but they were able to get other jobs, and that made up for the shortfall. So their income was not affected. Food production was affected, income was not affected. But in the other areas where there were none, their overall income actually declined. They could not substitute. So if you care about the income side or the food production side more, is depending, you know, what you take away from that. There is some optimistic angle to that also, that if you have more manufacturing growth, more non-agricultural development, it can absorb all these people who are like losing access to water, and their incomes can be sustained, it seems. So that's the optimistic side of that. Not really, because it's just so technically difficult to track these people over time when they leave the villages. We didn't have the means to do that, but I would have loved to been able to do that, but I just didn't know how to.
Not like that, people don't migrate far away places. There are some states wherein, due to several challenges related to water, people might be migrating to farther away cities.
Yes. So I wish, you know, our research design was not, didn't have the capacity to look into that, but I think that's another great thing to develop this further and to explore that. I wish we could.
Question is also, what was their knowledge base when they were picking these jobs? Meaning, did they know about the alternative technology? So,
Good question. Here is also something we actually did not take care to observe, unfortunately. So we asked them about the different things that they do that we knew of, and they were familiar with them, but most of them were not. We didn't see that they were more likely to implement them as a response to this water scarcity shock. But I can tell you something more in depth about how familiar they are with the range of different solutions. That's a good question. That's another limitation.
Is the timeline of these studies, because I believe that in Gujarat all these studies are there, where I think because of the irrigation, because of Narmada dam and canal, suddenly the entire region which did not have water got water, and they got adopted to technology because that is the only. So if it is around that span, then there is an explanation.
Some of these areas, so where we did the study, we were careful to avoid those areas. But it's true that some of these areas, they're starting to bring lift schemes to bring the water up from Narmada or other projects. And some of the farmers in some places were actually saying that's the only solution. Yeah. But within the area, so we were careful to identify very, you know, small distance variation in these things. So let me move to incentives. where we'll finally have something blue, so we can cheer up a little bit. And of course, incentive for us is, it's no need to explain this to an audience like this. The fact is that in India, like many other countries, there is basically zero regulation of pumping groundwater. That's not priced either. And in some places in the world, the power used to pump the water is priced, but in many states, most states in India, that is not priced. So even through the electricity, there is very little pricing, volumetric pricing that could maybe encourage more efficiency and conservation. And so the theory is that if we were able to somehow, and by the way, this is just a picture, because there's no regulation and no pricing, there's also no monitoring. So, there's very few, I have not seen even one irrigation pump in India that actually has a meter. This is one of the ones we're actually installing them in Punjab. We installed a few dozen just to get some of the first data on how much water is actually used. But these are very uncommon. So there's no metering, no regulation, no pricing. And of course, as economists, we believe that that's a big issue that's preventing farmers from using the water efficiently. Now, part of the good news and the reason for hope is coming from your colleague, Disha, whose paper actually uses very detailed farm level data. I hope I'm representing it correct. Correct me if I'm saying it wrong, but to actually prove, to estimate the returns to water from the way farmers actually use water in Punjab to grow rice and wheat, and to actually prove that once you estimate that response curve, you can prove that if the farmers face a certain price on the water or on the energy that they consume for pumping, then it would be rational and profitable for them to dramatically reduce the amount of water they use. Fair? Feel free to correct me, no? So this is really important because we didn't know that. One of the theories could have been that the return to water is so high that even if you actually price the electricity for pumping at its full price, still it might not have had any effect. This proves that it should have an effect in the sense that the marginal return on the water is actually substantially lower than what the marginal cost on the pumping would do. Fair? Correct? You can tell me if I'm getting it wrong. Now, yes, please. Please.
One of the problems all over the country, the last 3 decades, because of the pricing. They're extremely thirsty. Rice and sugar. And now they have shifted very considerably from their natural agro-climatic agricultural bases to sugar being produced in Gujarat and various other places. Not the habitat. Maharashtra, UP, and a few other places. Cultivated everywhere. Right now, that is precisely because many of the things are happening to the contrary of what. So water not being monitored, so they have been doing, and combined with the fact something which is I want to generally focus on the study, combined with the fact that the marginal part, small part, or the dominant part, they hold more than 2/3 of the land holding. So the question of externality here is very important. What happens to me is very small part of what happens to the water that is flowing out. And that is also one of the reasons why I raised this question of evaporation. So the economic policy at the government of India level, it drives towards many other problems. I think very responsible for this, contrary to what they're doing.
Again, sir, I very much agree. You're perfectly on. That's exactly the point. And from the point of view of how I'm structuring the discussion. When I talk about a technology that can help save water or use water more efficiently, from that perspective, growing rice or growing sugarcane is a highly inefficient technology of using water. So one of the things we might expect farmers to do to solve this problem is to shift from these water inefficient crops to things that are more efficient. And like you say, as far as I know, in Punjab, paddy cultivation was not so common before all this tubal irrigation came in and all these canals came in. I don't know what's the history of sugar in Gujarat or Maharashtra, but I would also tend to believe that without all this irrigation, it would not be possible. We just spent the last few days exactly seeing sugar farmers south of Pune, and totally agree. So one of these what I call technologies would be shifting from sugarcane or paddy to other more water efficient crops that produce the same amount of profit or the same amount of calorie, whatever your preferred outcome is, per liter of water. Now the question we're asking, why? What could drive farmers to make those shifts? And now we're asking that it's a very wide-held consensus that if prices were put in place, if farmers had to pay for the water, or at least if they had to pay for the electricity they used to pump the water at the right cost of production, then we would see these things start to happen. Many people believe that, but what do we actually know empirically about that? That if there was a price, would we see that people would start to actually, the farmers would make those shifts? Stop growing sugar, stop growing paddy, move to jowar or whatever, and would they maybe irrigate more efficiently or structure the irrigation scheduling? This is what we're asking. And I want to just review what the empirical evidence on that says. Because otherwise it's a theoretical assumption. What do we know from the field about what happens when you introduce these incentives? Now this evidence tells us that it should work, that it would be rational, in fact, for the farmers to make those shifts. Maybe not shift, this is not about shifting from paddy to other crops. This is while growing paddy to reduce the amount of water you apply to the field. And according to these calculations, that whatever decline you will face in your yield will be more than offset by the cost of what you would have to pay for the pricing. So it would become more efficient. Now, on theory, that is if farmers are actually maximizing profits rationally. But that doesn't mean that this is actually what's going to happen in the field when you introduce those prices.
But also to areas where water is depleted, scarcity is being observed.
So that's a good question. This is from Punjab. In Punjab, the water table is rapidly falling everywhere. So there's a lot of concern, but it has still not gotten to the point where the farmers do not have enough water to irrigate their most land. All land is cultivated with paddy basically in the Kharif. So the scarcity is not yet felt, and that's exactly why maybe if you introduce now the price on electricity, this should get farmers to use less water because they will have the incentive. So this is proving that they should be doing that if the price was introduced. But I'm saying there's another step beyond this in terms of a field study, that this assumes that farmers are rational and profit maximization, and we know everything that goes into their calculations. It may not actually be what's happening in the field, so we have to test this through an experiment. If you introduce the pricing, what will actually happen? And I want to describe to you 3 studies that actually tried to do that, okay? Now, how do those studies do that? So we have one study in Punjab, one in southern Gujarat, and one in northern Gujarat. As usual, my study is the one in the red, and the other 2 are blue. So the blue is in majority here, and that's optimistic. The first one was done, we were involved in Gujarat, and that's like a decade ago. And the idea there was the government, see, when you try to get the government to try something like this out, they're very reluctant. This is a huge political issue. How am I doing on time? Half an hour? So I'll try to speed up a little bit. So the idea, it's very hard to get, it's a very difficult political issue to price water. Like every politician that tried to do it is retired early, let's say. And so bureaucrats are very wary of trying to do that. And actually there are good reasons, because the burden that could put on farmers is something that needs to be thought about. So in this study in 2016, I was then with the Columbia Water Center. We convinced the state government to try something a little bit different. The idea was, we know you guys can't charge farmers for the electricity to pumping, but let's do it in a roundabout way. You're going to tell the farmers that whatever electricity they are using now, they are free to use as normal. But if they voluntarily reduce the amount of pumping that they do, for every 1 unit of electricity that they use below the benchmark, the government is saving money, right? Because the government doesn't have to give them that free power. So the government will give them a reward of, in our case, they agreed to give 3 rupees per unit. And the idea was, this is a roundabout way to you introduce an opportunity cost on the use of the electricity, right? It's not exactly the same as charging for the water, but it would be the first time that farmers would face a volumetric electricity cost on using, and in theory, it should introduce an incentive to use it more efficiently, the resource. So it's kind of a politically friendly way of introducing an incentive to pump efficiently. The only concern was, though, that for that to work, you need to meter how much they're using, right? And there is a great mistrust between the farmers, the utility, and the government, when the farmers are very wary that those meters would be the first step towards actually charging them from that. So most people were of the opinion, the expectation of most experts we discussed this with was that if you could do it, it would work amazingly because the incentive would transform the way they do agriculture, the way they use water. But it's not going to work because the farmers are so suspicious that they will never agree to install an hour meter. What we found was exactly the opposite of these two predictions. Not exactly, because there were some farmers who were suspicious, but working with the utility, we did manage to convince most farmers to go for it and to have a meter being read for this purpose. But there was no effect on their use of and how they did irrigation. There was no reduction in the amount of electricity that they were using, which was very disappointing and contrary to all expectation. And this is despite the fact that in the first monsoon season of the study, the rainfall was really good. So the farmers actually didn't need to irrigate as much. And suddenly they've been getting these transfers from the utility, and they were super happy. They said, this is a great policy, a great program. But when you compare the control and treatment group after a whole year, there was no difference. So it doesn't look like this incentive actually made them change anything. And that was very disappointing. But luckily, there are 2 other studies that followed later and actually did find responses. One was in southern Gujarat by Haggerty and Zucker, and they actually found pretty substantial reductions in the amount of electricity used for pumping. I don't know what the difference is. It could be many reasons. And there was another study in Punjab also, recently published in the AJAE, that also found they also find between 7.5% and 30% reduction. This study found 25% reduction. So they proved actually that this system can work quite well and reduce a lot of the energy use in agriculture. So quite optimistic. Another really interesting study in Bangladesh found mixed results. And it's a more nuanced picture. I'm going to rush ahead because we're a little bit short on time, but these studies, they do offer some hope that this could work. One of the problems, however, is that this is very difficult to implement, it turns out. The utility is not, and maybe that's the reason that the governments are not jumping on this and expanding. For the utility, this turns out to be very difficult. The metering, the billing, all this is one important issue with this. Another very important issue is that it's hard to figure out how to give those entitlement of the power from which you reduce. Do you base it on current usage? Do you base it on land holding size? What do you do about farmers that don't have their own pumps but buy water in informal water markets from those who own pumps? They're not going to get any incentive, and they'll face a hike in the price of water. So this is actually very difficult to implement, even if it could work. And so there needs to be much more research done on this. It's showing some promise, but a lot more research is necessary here. Finally, let's talk about what governments love to do most. Rather than remove one subsidy, they prefer to introduce another subsidy, right? That's what politicians, bureaucrats is the preferred way of dealing with an issue like that. And the technology here is, again, quite simple. We know that when expert agronomists use technologies in controlled trials, these things save water. That's been proven again and again for many of the technologies I mentioned. So why don't we go ahead and take some of these proven technologies and push them to farmers through extension, especially through subsidies, whatnot. And the theory would be that that would lead to adoption, that subsidies and extension, whatever, would lead to more adoption, that would then lead the farmers to use these technologies in the appropriate way to actually fulfill the potential of the technology to save water. And that would lead to actual water saving. That's the way the theory goes, and that's how we could deal with this issue. What do we know about this in practice? So I want to, again, 3 studies. Again, the 2 studies I'm involved in are red, and the 1 study I'm not involved in is blue. The first 2 studies, these 2 are involved with drip irrigation, okay? So in Gujarat, it's really using data on a massive deployment of drip irrigation through a government subsidy. And in Andhra Pradesh, it's around a similar program. Let me get into a few of the details. So specifically here, there's a big government effort to actually improve water use efficiency. It's a big agenda for agricultural development here. And part of these subsidies are concerned specifically with micro irrigation. So I'm very happy that as an Israeli, you guys are helping boost up the income of our companies, because some of these big irrigation companies are actually selling a lot, and a lot of it is actually funded by you guys, the taxpayers. So thanks a lot for that. Through these subsidies, which are actually, depending, there's a central government component, there's a state component. In some states, it reaches the total subsidy 90%. In some states, it's 50%. In some states, it's effectively administered. In some states, less so. But even though it's still a relatively small fraction of Indian farming, you actually, if you go to certain parts of India, you will see quite a few of these systems. Where we were in Satara in the last few days, you see quite a few sugarcane farmers actually using drip irrigation. And Gujarat also is one state where it's very prevalent. Oh, come on. Oh, shoot, I sent you the PDF. I have a super nice animation here where we actually took data from the government agency that distributes a subsidy, which actually, we know every single case of 500,000 adoptions of drip or sprinkler. They are recorded by this agency, the Gujarat Green Revolution Company, and you have the coordinates and the time of adoption. So we have all this massive data, and we actually put it on the map, and you can see beautifully, you'll just have to take my word for it, unfortunately, how the technology spreads at the village level. And it's beautiful to see the diffusion. I'm so sorry that I blanked out on this, but actually it's between 2005 and 2014, you see enormous numbers of adoption of these technologies, reaching about 500,000 farmers adopting them, okay? And using this data, there's a bunch of things that we can do to learn about the question we just asked. First of all, we can see that the subsidy itself has a big role in the adoption. So if you ask whether the subsidies lead to adoptions, we do find evidence of that. We utilize variation in the level of subsidy in time, space, and with certain irrigation technology providers. So we use that, we find a substantial increase in the adoption when subsidies are increased a little bit. That's not obvious, because you might have thought that people who adopt with a subsidy would have also adopted without the subsidy. But this evidence suggests the subsidies lead to additional adoption. So that's the first arrow in that theory of change, seems to be to have some empirical backing. What you don't see, unfortunately, is that it leads to smaller farmers adopting when the subsidy, it's the same type of farmers, but there are more of them. So this arrow is actually, we can make it a little more solid and dashed, okay? But if you look if you want to know whether that actually saves water, here it's a little bit less encouraging. We were able to obtain the electricity accounts of a few thousand of the farmers that they're pumping bills. These farmers are actually billed. Some farmers in Gujarat are billed at a very low rate, but it is volumetric. And we can use those accounts to see their consumption of electricity for pumping, how it changes in the year that they adopt the micro irrigation. And if the experts were right, we would expect to see a decline here. But what we see is actually an increase in the first year. which is contrary to expectations. What could be going on? A bunch of things could be going on. There's a whole literature on the rebound effect or the green paradox, if you've ever heard of it. That sometimes when you improve the efficiency by which a resource is used, sometimes it becomes more efficient to use more of it. Sometimes you expand to more area. So there's all kinds of things that could happen here. Sometimes maybe it's a technical thing where you need more energy to pump into the drip system. We don't know, but we see at the short term actually an increase. Later we might see a decrease, but it's becoming more uncertain and less precisely measured. So right now we're still working on this, but we don't see any clear indication that at least in the short run, that there's actually using less energy after adapting the system, and I'll come back to that in a second. And this connects to the other study in Andhra Pradesh, where we actually ran an experiment. The experiment was to actually randomly take some farmers and fill in the missing subsidy that is required to cover the entire cost of the system. Okay? And the idea was to see what is the causal effect of adopting this water-saving technology. What we found was basically that there was an increase in adoption, actually much smaller than we expected. We found, I'm not going to do the charts though, because we are running out of time. We found that the increased subsidy led more farmers to adopt the drip irrigation. We found that it increased the productivity, but when we checked how long they operate their pump for, which is a proxy of how much water they use, there was no effect at all. Okay, so the adoption, like the previous chart, the adoption of the drip irrigation did not lead to a reduction of how much water they pump or how much electricity they use to pump the water. What's the explanation for that? Any thoughts? What could be the reason that you adopt a water-saving technology, but there's no indication that you are pumping less water from your well? Sorry? Multiple cropping. Most of them already did multiple cropping, but that's exactly the direction. Expansion of area. This is a context where farmers are not able to cultivate their entire land during the dry season because water is not sufficient. Once you can use the same water to improve efficiency, rather than using less water to get the same area, why don't you expand your area, use the same water to cultivate more area? Wouldn't that be the rational response if you're not paying for water? And that's what's happening. So that's not super surprising, but it would good to see that in fact, even farmers who do cultivate the entire area turn out to sell water to farmers around them or to give it to their relatives. So that's actually what you would expect. And in many parts of India, where land irrigation, cultivation is constrained by water, you would expect that to be the first response. What would happen if you did this in Punjab, where all the land is saturated? I don't know. Maybe there we would see saving in water, but we need a study like that over there. So that's as far as that goes. And finally, good news from Bangladesh, from these co-authors around alternative water and drying. They were able to actually see, they had two types of farmers in Bangladesh that were in their sample. Some had a fixed price they were paying for irrigation, so no marginal volumetric price. Some were paying a volumetric price. This is in Bangladesh, so there was a system where they did have to pay. And there, they saw that there was increased demand Then they introduced alternative wetting and drying to these farmers through a technology dissemination campaign. And they were able to see there a clear difference, a clear effect of the technology, use less water, but only amongst the farmers who were paying for the irrigation volumetrically. So this is the first study that actually combines both the technology dissemination and the pricing to see that together they do seem to have an effect. But each one on their own does not seem to have an effect. So I think in terms of more research on this, we need experiments that actually combine the two in the Indian context also. And the one study in India, which is also positive, also around alternative watering and drying, actually, without any price, they claim they were also able, through an informational campaign around alternative water and drying to actually reduce water use. So I think this is where we are right now. No evidence that scarcity is working. Some evidence that the incentives could be working, but very difficult to actually implement. And in terms of technology, also a mixed picture. So no clear answers yet. I think moving forward, we need much more evidence on these questions. Again, maybe one promising direction to go is to combine technology and incentives to see whether they work well together. But how do you create the incentives is a very difficult question. It doesn't look like governments here are very excited about expanding the kind of programs that I described before. I think another interesting place to take it is to take a model which is more like payment for ecosystem services. So there are many programs around the world where you pay farmers for taking certain actions that are easily measurable and verifiable and paying them a flat rate for these actions. For example, you can pay farmers not to cut down their forests, or you can pay farmers to plant certain, like to leave certain parts of the land with more wild crops or wild vegetation, and you pay them a fixed rate for that. So it's not payment for water saving, but it's payment for specific actions. For example, what if we paid farmer to practice certain things that are proven, not volumetrically, but with a flat price? This is the second best approach, but I think it needs to maybe be investigated empirically more carefully, because this is the kind of program that is easier for governments to implement. And even though they may not be optimal, maybe they'll be more scalable and still be improvement on the current situation. And I want to end with just asking again, as I promised in the beginning, about maybe also as economists, in just 2 minutes, it's worth for us to take a bigger perspective here. And the idea again was that if we look at the development context, and that's broader than just the water and agriculture, when we talk about adaptation, maybe we don't need that to be limited just to adapting agriculture, just farmers adapting to water scarcity. Maybe we should take a broader perspective in which even if farmers shift their labor away from agriculture to other types of income generation in response to water scarcity, at least from the perspective of development of these communities, these farmers, this could still be considered to be an effective way to adapt to this growing water scarcity. And in fact, in environmental economics, there is a long tradition in which economists, starting with Solow actually, when they thought about what sustainability means, they said, well, natural scientists think of sustainability as meaning that natural condition resources are not being depleted. But as economists, they developed a broader perspective, sometimes called weak sustainability. And the weak sustainability paradigm is about maintaining consumption or income even while resources are being depleted. And if we apply that perspective to the context of an Indian farmer, then again, even if they fail to adapt within agriculture, maybe they are able to adapt in a broader way by finding the means to shift away from farming successfully. What do we know about the extent to which that is happening? And especially, you could think of a scenario or a way to look at this in which after decades of exploiting groundwater, in the weak sustainability paradigm, the theoretical foundation is that if you take the profits from depleting a resource, a natural resource, and invest it in other types of capital that can substitute for the resource, that from that perspective, you actually might be able to maintain your income over time. That's what the weak sustainability paradigm is. Perhaps you've heard of the Hartwig rule, and that's basically the recipe that tells you how to invest all the profits from exploiting a mineral into man-made capital. So maybe, in effect, if Indian farmers had done that, maybe while depleting their freshwater, if they used those profits to invest in other types of capital, for example, in human capital, through education, that can be something, an asset, a type of capital that can enable them to transition from farming to off-farm employment while maintaining their income. That is a whole different scenario than the usual way that we look at this unsustainable use of water in India. Maybe Indian use of water has actually been weakly sustainable in that sense. maybe it actually is an effective development strategy to deplete that kind of natural resource in order to empower and enable the farming workforce to transition out of farming through investments in education, for example. This is something that's seldom considered in the context of the way India has been using its groundwater. And I'm not saying that it has been weakly sustainable in that sense, but I'm saying it might have been. And in fact, one recent evidence that we tried to gather on that is to see whether in those locations in which there is more groundwater, and geologically, again, these are all the blue areas here, are areas where aquifers are alluvial, so they store much more water than everywhere else. We took data from the NFHS that provides you village level information geocoded on health and educational attainment. And we compared villages within the same district that are in the blue areas and the non-blue areas. So these are all the red points here are the NFHS clusters, villages used in the sample. We compare people whose villages are over the blue areas that have a lot of groundwater to villages that are not over these alluvial aquifers, have less water. We confirm that they irrigate more, and we see a clear difference in the amount of schooling and educational attainment that they have. That is one component that might be needed to enable the use of, and we interpret that as indicating that access to the groundwater and the income from that, the profit from that, has actually enabled those investments in education. Okay, if that interpretation is correct, it may mean that the exploitation of this resource has been basically shifting your capital from one that includes the water capital to human capital, more education. That has fueled the education of this labor force, and then maybe that was sufficient to enable them to find other sources of income generation and employment. So that's just one small step in a research program that can try to ask whether maybe in fact from the weak sustainability point of view, India's use of groundwater has not been as unsustainable as we normally think. But no conclusive answers yet, something that needs to be thought about, and it doesn't solve the food problem. The food problem is something that needs to be dealt with because even if they are able to transition, what is really required here is also to maintain food production. And even if all Indian farmers succeed in shifting away and going to work in servicing or manufacturing, if India produces less food, world food prices are going to go up a lot, and that's something that also needs to be considered. So I'll end here. I know there are a lot of questions, and because there are so many questions, I want to encourage all of you to maybe work on these problems. They're so important and interesting and difficult, and we're always looking for more partners to collaborate with. So I'd be delighted if any of you would be interested in doing that or helping us work with more partners to do more of these field studies that need to cover India's entire map. So we have much more evidence to base policy on. And thank you very much for this opportunity.
Thank you very much, Professor Fishman. That was a very, very insightful talk. And, I have particularly more interest into all this stuff because this is related to my own research since my PhD time. So thank you very much for, summarizing all kinds of studies that we have on water issues in India and elsewhere surroundingly. We have a few minutes and maybe we could take, 5-10 minutes extra. Are there? Yes, please go ahead.
Just a small observation is that when you talked about the incentives for judicious use of water, you only focused on monetary incentives.
On monetary
incentives. Traditionally, Indian societies care about the natural resources, even though there are conflicts of common property and the personal interests, but still, say for example, the communities which primarily depend on forests, they historically have had a norm of preventing the forest as well. They worship the forest, worship plants, right? And if such kind of behavior is or norm is also gets established in terms of uses of water, then the norm will guide them to use it more judiciously. And perhaps there is a scope for non-monetary incentives, so social status kind of incentives, even in the context of groundwater depletion to put under control. So what's your thought about that?
I think that's a very important point. And I guess I didn't emphasize that because I'm not aware of any studies that have examined those kind of interventions. But I actually fully agree with you that they deserve a place in the conceptual framework. They deserve to have a place of mention as another possible approach to non-monetary incentive or basically community management of the resource. There's one study that I'm familiar with that was involved with a program like that in Andhra Pradesh that was called AP Farms. They claim that through educating the experience on the dynamics of aquifers and what makes water tables go up and down, that they've been able to affect the change in how they used the groundwater. But it was not. I didn't see any evidence that was rigorous evidence of that impact of the kind that we like to see, with counterfactual, etc. So I didn't include it here, but anecdotally, that was one claim I heard about that particular project. But I fully agree, this is something worth exploring more and seeing.
Because I say this because there are some evidences in terms of ecological balance maintenance in the context of wildlife protection in Scotland. There are some evidence of that there is if you provide some status incentives, farmers to care about wildlife protection on the farm and status incentives.
I see.
There are
Status
norms.
incentives, yes. It's very interesting to explore that.
Thank you.
Yeah, may I? Yeah, thank you. It's excellent talk. It's a very broad canvas. I just wanted to put in one thing. There were many questions, I'll avoid that. But the one thing I wanted to put in, which is possible to widen within the scope of your study. Have you considered the millet as a crust substitute? Because it preserves all aspects like food security, nutrition, and on top of everything else, it is a lot more sustainable in terms of water.
Yes, sir. So again, I think that, let's say, shifting from rice to millet, for example.
Completely, but a substantial which is.
So to some extent, any acre that you shift from rice or from sugarcane or even from wheat, I think, to millet would save water. And so that I would consider millet as one of these technologies that we want to see a shift towards. The question I try to pose here is what would push farmers to make that change? What is needed to make that change? So we considered incentives, we considered maybe more extension. I think in the case of crop shifts, one more factor to include here are market prices. That probably has a strong influence. And actually, there is a recent study that showed that market shifting, that rice is very much associated with more water depletion, and suggesting that incentives to shift crops, like changing the market prices. Let's say if there was a good MSP for millet, what would that do to the shift towards millet, and as a result to water consumption, is a super interesting and important question, but there is no study that actually I know experimented with that.
I know it just started. It's a millet, as you know very well, is a generic word. Okay, it has a lot of variations in South India, agroclimatic conditions. They grow different. Gujarat, they grow different. Maharashtra, very successful, and they keep all the other parameters in a better shape, and yet saves a lot more water. I mean, I know not much work has been done. That is the reason I'm saying, going forward, would you consider doing something like that?
Yeah, I would love it if any state government were willing to work on an experiment where they would like incentivize millet production through like a good MSP or something, and to see what would actually happen. I do want to raise one point here though. It's true that like, what about the scenario? Why might farmers not want to shift to millets fully, and why might the government not be willing to push millets very aggressively? Because now that we go to lunch, how would we all feel if there was no rice on the plate? If the chapatis were made out of millet and not out of wheat? I'm not sure that as consumers, we would be very happy with that. And I think the Indian government would be very worried about trying to push millets aggressively to replace all and buying all that millet from farmers, because I'm not sure we would be willing to buy that millet from the government, and that people who depend on PDS would be willing to receive millet instead of rice. I don't know, but I think it's something to think about. Again, connected to what Alon, my colleague here, is an expert on, how dietary shifts can change the environmental picture of food production. So that, which he will talk about in the afternoon. But I think it's a big unknown. I don't know the answer to that. I think we don't have good evidence of that, and I wish we could do some experiments with that. So if you have some connection with the state government that would be willing to run an experiment like that, then I'd be.
I think state governments have started. And
It's true in Haryana and Punjab. There, it's starting to.
and Orissa also has started.
Orissa also, okay.
So there is a millet mission, and at the same time, I think the G20, which was held in India, they had pushed millet as a very important thing. So I'm just saying there is a way forward. The government is very aware of this.
So this is again technically, agronomically, there is so many ways to save water. The question is what will bring there to their adoption. Alon?
Comment. Important that I know the research also that looked at changing rice varieties in India as a way to mitigate some of these border issues. Right. And so, like was mentioned here, even changing rice within rice.
Dietary habits.
Yeah, it's a very cultural habit of, imagine not going to millet, but going to wild rice, maybe going to rice with a different taste. So I think those are really cultural gaps that we need.
We'll hear you in the afternoon on that, all that.
You wanted to say something? You wanted to say something? Oh. Oh. Mm.
From even the variety of rice.
Mm.
But to eat other variety of rice, they generally complain that those who are less water intensive, they taste bad compared to those who they are normally grown. Right. By the way, they are more in many ways. They're sometimes in most cases, I think they have more micronutrient dense food. They're more healthy to you than just plain white rice. So that's another issue to consider.
So who's giving up their rice today in lunch?
When we were talking about scarcity, you talked about how we can't look at the simple correlation between rate of depletion and what farmers are actually doing. And you talked about how there are some confounding variables that might be affecting it. Would you mind explaining it again?
Absolutely. So imagine that we do, our research design is, we want to know how scarcity affects technology adoption or crop shift or whatever. And we look at different villages and we measure the water table in each one of those villages and how fast the water table has gone down. And then we test whether in those villages where water table is deeper or going down faster, do we see farmers shifting technologies more? So that would be interesting, but it wouldn't prove that it's a causal relationship, because one of the possibilities is the villages where the water table is going down faster, maybe those farmers to begin with are more entrepreneurial, maybe they are more wealthy, so they have bigger pumps or something, and that's why the water table is going down there. And if we see those same farmers adapting more advanced water management technologies, maybe it's not because they're facing more scarcity, but because they are, better farmers to begin with. And we would wrongly think that it's because of the scarcity. So that is a kind of confounding factor that could bias our interpretation of that correlation. And so when we look at like exogenous variation in what drives differences in the water depletion, for example, the geological structure locally, that gives us a more reliable, more causally interpretable interpretation of the correlation we see.
Small thing. I like the idea of your weak sustainability that you mentioned. We should perhaps think of funding migration out of the country. That's also a weak sustainable strategy for farmers in Punjab, especially.
Yeah, you said the poor thing. I would say on a serious note on that, another very big question I think that's very important What happens when small farmers exit farming? On paper, that could be an opportunity to transform farming. It's easier to regulate a few bigger farmers. It's easier to regulate more commercial farming. They're more technologically advanced, maybe more open to technological transformation. But what actually happens? What actually happens when there is shift of small farming? First of all, do they really give up their land? Is there land consolidation? Are the remaining farmers really more efficient in how they use resources? This we know very little, and I think that's also a very important research agenda because these processes are happening, right? You don't see many young farmers when you go out there. They're all in the cities. What is going to happen when like their fathers start to retire
The
from
clue to why things are not changing really was during COVID. When COVID hit, huge number of people went back to the village.
Yeah,
And they had the land back.
right.
So that insurance component that the land gives is still the truth. Why transformations are not happening?
We'll see him right.
Which only points to the fact that the non-agriculture is not providing the sustainable livelihood. I agree with you that you have to look at non-agriculture, but
Yeah.
in fact, I recall a comment which Professor T. N. Srinivasan made long ago in a conference. The problem with Indian agriculture is not doing the right things yet.
So I think there is so much need for more research.
There's a lot more.
I'll give you one more small example we see in the fields here. We see that there are farmers, so I told you drip irrigation is quite prevalent. Now with drip, you have to apply 1 hour of irrigation every day. That's part of the way you get the optimal amount of moisture to the crop. When you flood once for a few hours, the whole field gets, and then for 2 weeks, it takes 2 weeks until you need to flood that field again. Now, if you have another job, if you're not, many farmers are not full-time farmers, right? They have another job. So for them, the ability to turn on the pump one day, the whole day, and come back after 2 weeks while they do their other job, it's very important. They can't go to the field every day to turn on the drip. So you see another interaction here between the off-farm employment and the on-farm employment. And again, I think this is a super interesting and important area of research on which we know very little. So another for PhD students, like something to work on.
All right, so we are already out of time, and I'm sure that many of us still have some questions and some interesting comments to make for Professor Fishman. And I encourage all of you to speak to him after post lunch. He would be available in RB 3201. So if you would like to interact with him, please feel free to walk in and come. If you want to drop an email, you can drop an email to me and set up an appointment separately with him. I would encourage especially all the PhD students to come over and speak to him. He's available today. He would be leaving tomorrow morning, so he's available today before dinner. So you should really come and talk to him. Now I invite all of you for a group photograph outside. And I would like to thank Professor Fishman for coming here, for delivering such a nice talk, and for patiently answering questions, and also giving all of us some more research ideas. So I would also encourage our PhD students to think beyond and think about such ideas that he's discussed today. Thank you very much.
Thank you. Thank you very much. Thank you.